Welcome to the enigmatic world of quantum mechanics, where the ordinary rules of physics give way to a realm of astonishing possibilities. Today, we embark on a journey to unravel the mysteries of quantum physics, a field that has puzzled and fascinated scientists for generations. Prepare to delve into the heart of matter and energy, where particles can exist in multiple states, teleport across space, and become entangled in ways that defy classical understanding. Join us as we explore the secrets of quantum mechanics, a theory that not only challenges our perception of reality, but also holds the key to revolutionary technologies of the future. Quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales, is a theory that has reshaped our understanding of the universe. It describes a world where particles such as electrons and photons can act as both particles and waves, a duality that is central to the quantum realm. One of the most intriguing aspects of quantum mechanics is the principle of superposition. This principle states that particles can exist in multiple states or positions simultaneously, as long as they are not observed. It is this property that Schrödinger's famous thought experiment, involving a cat that is simultaneously alive and dead, illustrates. Superposition is not just a theoretical curiosity. It is a fundamental aspect of quantum computing, where quantum bits, or qubits, can represent a 0, a 1, or both simultaneously, enabling complex calculations that would be impossible with classical computers. Another quantum phenomenon that challenges our classical intuition is entanglement. Entangled particles become interconnected in such a way that the state of one particle instantaneously influences the state of another, no matter how far apart they are. This spooky action at a distance, as Einstein famously called it, has been experimentally confirmed and is a cornerstone of quantum cryptography, allowing for secure communication that is theoretically immune to eavesdropping. Quantum mechanics also introduces the concept of quantum tunneling, where particles can pass through barriers that should be insurmountable according to classical physics. This phenomenon is essential for the functioning of technologies such as scanning tunneling microscopes, which can image individual atoms on a surface, and flash memory, which stores data in semiconductor devices that utilize quantum tunneling for reading and writing information. The Heisenberg uncertainty principle is another cornerstone of quantum mechanics, stating that it is impossible to simultaneously know both the exact position and momentum of a particle. This principle does not stem from a lack of measurement precision, but is a fundamental property of nature, highlighting the probabilistic nature of quantum mechanics and the role of the observer in determining the outcome of quantum events. Quantum field theory, an extension of quantum mechanics that incorporates the principles of special relativity, provides a framework for understanding the fundamental forces of nature and the behavior of particles at high energies. It has led to the development of the Standard Model of particle physics, which describes the elementary particles and their interactions, and has been confirmed by numerous experiments, including the discovery of the Higgs boson. Quantum mechanics also provides insights into the nature of time and space. The theory of quantum gravity, which seeks to unify quantum mechanics with general relativity, explores the possibility that space-time itself may have a quantum structure. This could lead to a deeper understanding of black holes, the Big Bang, and the fundamental nature of the universe. In the realm of condensed matter physics, quantum mechanics explains exotic phenomena such as superconductivity and superfluidity. Superconductors are materials that can conduct electricity without resistance at very low temperatures, a property that could revolutionize energy transmission and lead to powerful magnetic fields for applications like magnetic resonance imaging (MRI). Superfluidity, on the other hand, is a state of matter where a liquid flows with zero viscosity, climbing up the walls of its container and demonstrating macroscopic quantum phenomena. Quantum mechanics has also given rise to the field of quantum chemistry, which applies quantum principles to understand and predict the behavior of chemical reactions at the molecular level. This has led to advances in drug design, material science, and the development of new catalysts that can speed up chemical reactions in a more sustainable way. Moreover, the study of quantum mechanics has philosophical implications, questioning the nature of reality and the role of the observer. The Copenhagen interpretation, one of the earliest interpretations of quantum mechanics, posits that quantum systems do not have definite properties until they are measured, suggesting that the act of observation plays a crucial role in the fabric of reality. Other interpretations, such as the many worlds theory, propose that all possible outcomes of quantum events actually occur in separate, parallel universes. As we reflect on the profound implications of quantum mechanics, we are reminded of the boundless potential that lies within the quantum realm. This theory, which has reshaped our understanding of the universe, continues to challenge and inspire us, pushing the boundaries of what is known and what is possible. In closing, let us celebrate the enduring legacy of quantum mechanics, a theory that not only advances our knowledge of the natural world, but also propels us into a future filled with technological marvels and philosophical insights. As we continue to explore the quantum universe, let us do so with an open mind and a sense of adventure, for in the quantum world, every discovery is a step toward a new horizon of understanding. Thank you for joining us on this extraordinary journey through the quantum landscape, where the secrets of the universe are written in the language of probabilities and possibilities. As we return to the familiar world of classical physics, let us not lose the sense of awe inspired by the quantum realm. Remember, the cosmos is full of wonders waiting to be discovered, and curiosity is the key that unlocks them all. Until next time, keep looking up and questioning the cosmos, for in doing so, we continue to illuminate the path to a deeper understanding of the quantum world. Thank you for watching. If you're hungry for more knowledge, hit that like button and don't forget to subscribe. Your support is incredibly valuable to us.